Good day, everyone. I'm Bonete, and today we're gonna talk about work and kinetic energy. So let's get started.
Kinetic energy. What is kinetic energy? Kinetic energy is the mass of an object in motion. The faster an object is moving, the more kinetic energy it has. Thus, if we increase the mass of an object, the kinetic energy will increase as well, because these two are directly related to each other. Same goes for speed as well. But if we double the speed, the kinetic energy will quadruple. If we triple the speed, the kinetic energy of the object will increase to the 9th power. Hence, an example of kinetic energy is when an airplane is in flight. It has a large amount of kinetic energy due to its large mass and vast velocity. Work. Work means a force acting on an object in the direction the object is moving in, which means the force exerted should be in parallel or in the same direction of the object is moving in. So, how does work works? Well, work applies in everyday life, and you can see it anywhere. An example of work is when I push the table in the same direction.
Gravitational, elastic, nuclear, chemical, and electric potential energy. John Salgado, and we're going to tackle about potential energy. So, potential energy is the energy stored in an object due to its position and configuration. There are 5 types of potential energy. Those are gravitational, elastic, nuclear, chemical, and electric potential energy. Gravitational potential energy is the energy stored in an object due to the Earth's gravity. Elastic potential energy is the energy stored in an object due to its deformed state. Nuclear potential energy is the potential energy of the particles such as protons and neutrons that are present inside the nucleus of an atom. Chemical potential energy is a type of potential energy stored in the bonds of atoms and molecules. And electric potential energy is the potential energy that charged particles have because of its own electric charge and its relative position to other charged particles. I'll give you some examples of potential energy. The book. The energy stored in this object gets at the height of the book, and when I drop it, the book is applying force on the table and there is a small amount of displacement on it. I feel tired and need to rest a bit. Next is the rubber band. If you pull this rubber band, it has potential energy by stretching it. And when you release it, it applied the force on the object and there was displacement of it.
Your mark!
Hey, archers, to your mark!
And may the lucky arrow find its target.
Another example is the bow and arrow. When the string of the bow is stretched up, potential energy is applied with force and displacement. Nuclear energy is a source of power which is created from energy released by a nuclear reaction. An example of nuclear energy is the electricity generated by a nuclear reactor, which is the major power source used in Japan. The example of electrical energy is the rice cooker. It is plugged into a wall outlet and it takes the moving electrical charges, electrical energy, and changes them into thermal energy by causing the heat coils to get very hot for cooking. The example of chemical energy is food. It is digested to convert chemical energy into other forms of energy used by cells.
Now for the formula of potential energy. Potential energy is equals to mass times gravity times height, where mass is the weight, gravity is equals to 10 meter per second squared, and the height is the measurement of how high you lift an object.
Hi, again, so we're going to do the computation. Potential energy is equals to mass, gravity, and height. Let's assume the object has a weight of 3.5 kilograms. Acceleration due to gravity is, well, actually 9.8 meter per second squared. Trust me, do not believe on this guy. So anyways, the height is measured 0.5 meters. So let's substitute these three and multiply them. The answer is 17.5 and the unit is gonna be joule. A helicopter is flying at the height of 1.5 kilometers. If it has 50 meter joule of GPE, what is the mass of the helicopter? Another given is H is equals to 1.5 kilometers and GPE is 50 meter joule. So what if the mass is the one missing? Let's create a triangle. So we are going to find the mass. Simply cover the letter M and you'll see GPE over G times the H. So the amount of GPE is 50, so 50 divided by 9.8 and 1.5, if you multiply that, it will be 14.7, and it is equals to overall 3.40, and the unit is gonna be kilogram. Next is the book. where its mass is 1.2 kilograms and has a GPE of 23.5 joule. Now the height is what we're going to find next. So when we look back at the triangle, cover up the H, GPE over M times G. So 23.5 is over 1.2 times 9.8 is equals to 11.76. So overall it's going to be 1.99 or 2 kilometers, 2.00. So